In this video, we're going to discuss how to find a basis of the kernel of a linear transformation. So I have the same linear transformation we've been working with, T going from R4 to R3, given by a standard matrix written down there. But I also rewrote what T does to the vector x, y, z, w. Right? So we could also see this as sending the vector x, y, z, w to the vector 2x plus 4y plus 2z minus 4w in the first component, and so on and so forth. And we'll see why this is helpful in just a second. So just to recall from previous, the kernel of a linear transformation is all the things that get mapped to the zero vector. So the question we're asking ourselves is, what vectors x, y, z, w, when we plug them into T, spit out the zero vector? So in other words, what we need to happen is we need to have that first component equal to 0. We need to have that second component equal to 0. And this one was supposed to be a 0. And the third component needs to also be 0. So in other words, we need to solve a homogeneous system of equations in order to find the kernel. Okay? And so if we want to find a basis of the kernel, we are simply finding a basis of a solution set of a homogeneous system of equations, which is exactly standard V10. Okay? So let's finish this one out. We have written down a homogeneous system here. So in order to write down the solution set, we'll first need to find the reduced row echelon form of the matrix that goes with that system, which conveniently enough is the standard matrix for our linear transformation. So we'll use a calculator here to compute this. 1, 2, 0, 0, 0, 0, 1, 0, and our last row is 0, 0, 0, 1. So now what this tells us is that we can write a simpler system. So our first row says, oops, that was supposed to be an x, and that looks too much like a y. So let's try again. That first row says x plus 2y should give us 0. That's a better x. X plus 2y. Leave a little space here. Our second row says z equals 0. And our last row says w equals 0. So if we look up at our matrix, we have 3 pivot columns and 1 non-pivot column. So our non-pivot column will correspond to a free variable. So that was y, so we can let y be our favorite letter. I usually go with A. And then we can substitute in A for y, and then we can solve for x here. So x should be minus 2a, y should be a, z should be 0, and then w should be 0. So our solution set, the kernel, is going to be all of the vectors of the form negative 2a, a, 0, 0, such that a is any real number. Now to find a basis for the kernel, just like when we're working V10, we simply need to note that we could factor out that free variable here. Okay. And if we had additional free variables, we could factor those out as well. So what we end up with is a basis of kernel of T is simply the single vector negative 2, 1, 0, 0.